Methylene chloride is used for several industrial processes, such as paint stripping, pharmaceutical manufacturing, metal cleaning and degreasing, adhesive manufacturing and use, and many others. According to the EPA, miscellaneous uses of methylene chloride include use as an extraction solvent, including the extraction of heat-sensitive substances such as caffeine, cocoa, and edible fats, and processing of cellulose triacetate fiber. Some specific products include Savagron sprayable Stryprees, Champion spray-on degreasing solvent, Zinsser brush and roller wash, and many others. The general chemical structure of methylene chloride, or CH2Cl2, is a central carbon attached by a single bond to two chlorines and two hydrogens. Methylene chloride is not known as a persistent organic pollutant. How is methylene chloride introduced into the environment? Well, of the total methylene chloride released to the environment, about 86% is released to the atmosphere, 12% to land, and only 2% to water. Principally, atmospheric release is a result of industrial and consumer use, while land release is a result of landfill disposal, and release to water is a result of industrial effluents to surface water and underground injections to groundwater. When evaluating the risk of a contaminant for the U.S. environment, risk is defined as the probability that something undesirable will happen as a consequence of exposure to a hazard. Overall, methylene chloride is low risk to the U.S. environment. According to the EPA, about 85% of the total amount of methylene chloride produced in the United States is lost to the environment. However, because it is not deposited in high concentrations, nor can it accumulate to high concentrations, it is still considered low risk. Its main release to the environment is atmospheric, but it is considered low risk to the atmosphere because it has negligible photochemical reactivity due to hydroxyl radicals in the lower atmosphere that remove methylene chloride before it can reach or harm the ozone layer in the upper atmosphere. It is low risk to U.S. land and water because of its extremely low concentration in these mediums to begin with. Furthermore, methylene chloride poses a very minimal threat to present and future environmental safety in the United States. Because it has negligible photochemical reactivity, it does not create tropospheric ozone or smog. And because it is not a greenhouse gas, it does not deplete stratospheric ozone or contribute to global warming. The main potential threat comes from its ability to contaminate soil and groundwater because it is not readily biodegradable, meaning it cannot return to its natural state 60 to 100% within 28 days, even when exposed to sunlight, water, and microbial activity. However, even this is rather non-threatening because it is scarcely present in these mediums to begin with, and what is deposited is mostly evaporated to air. So, methylene chloride is low risk and non-threatening to the U.S. environment. But how long does it remain active in the environment? Most methylene chloride is evaporated into air from both soil and water. Of the small amount that remains in the soil, it is unknown exactly how long it remains, and of the small amount that remains in the water, about half of it will be broken down by chemicals and bacteria within about 6 days. Now, despite the majority being in the atmosphere, even this is not a long-lived presence. According to Dow Chemical, about half of the methylene chloride in air disappears in 53 to 127 days. As I've mentioned, methylene chloride is extremely volatile. Almost all the methylene chloride that enters the environment through soil and water is evaporated to air. Furthermore, the small amount that does not evaporate from soil enters groundwater and mostly evaporates from there. This property works in its favor as it is most easily broken down in air. So how is methylene chloride broken down? In each medium, methylene chloride is broken down relatively slowly, but again, its inability to accumulate keeps it in check. In the atmosphere, it is broken down by hydroxyl radicals. In water, it undergoes hydrolysis at variable rates depending on pH and temperature. In small amounts, it is biodegraded in soil under both aerobic and anaerobic conditions. In several studies, the rate of biodegradation was found to be dependent on soil type, substrate concentration, and redox state of the soil. Although methylene chloride is relatively unharmful to the environment, it has the ability to induce adverse health effects to many species. Humans are most affected by it because they are exposed to it in the highest concentration via indoor industrial and consumer processes. Unless it's present in extremely high conditions, methylene chloride is not acutely toxic to terrestrial species, and it has low acute toxicity to aquatic organisms. Lethal concentrations are generally greater than 100 milligrams per liter. While the effects of chronic exposure to minimal amounts of methylene chloride are unknown, acute exposure from inhalation, skin absorption, ingestion, and skin or eye contact causes adverse health effects to the nervous system and heart. In general, these effects are a result of the heart having to work harder and the blood being able to carry less oxygen as the body breaks down methylene chloride to carbon monoxide. Immediate symptoms of exposure include mental confusion, lightheadedness, nausea, vomiting, and a headache. If encountered in its liquid form in vast amounts, methylene chloride can induce irritation and chemical burn. According to the EPA, 500 parts per million of methylene chloride in the air over an 8-hour time-weighted average can be lethal. Occupational Safety and Health Administration standards set a limit of 25 parts per million over 8-hour time-weighted average and 125 parts per million for a 15-minute time-weighted average. Ultimately, intermediate and long-term health effects are the same for all life stages. However, the higher ventilation rate in children compared to adults means that for a brief period, children will be slightly more vulnerable than adults to acute neurological effects from short-term inhalation exposure. This is according to the government's Public Health and Human Services Toxicological Profile on Methylene Chloride. Studies that demonstrate methylene chloride's relation to other chemicals are scarce. However, this profile explains that the few that have been conducted have shown that it may have some synergistic effects. Methylene chloride with carbon monoxide increases COHB levels. COHB is a stable complex of carbon monoxide that forms in red blood cells when carbon monoxide is inhaled. Furthermore, methylene chloride in toluene retards embryonic growth and development. Several laws and regulations exist to control methylene chloride's use and application. When methylene chloride was listed as a hazardous pollutant in the 1990 Clean Air Act amendments list, voluntary reduction in the usage of it occurred in 1991 as a result of a joint industry and EPA pollution prevention initiative program known as the 3350. Still, several laws are in place to ensure its management, such as the Toxic Substances Control Act, the Safe Drinking Water Act, and Consumer Product Safety Commission, to name a few. Luckily, there are few possible substitutes that exist for methylene chloride. For many cleaning jobs, water-based and vegetable-based products are effective and safe. For decaffeinating coffee, ethyl acetate is an FDA-approved substitute. Though not as cheap or efficient as methylene chloride, benzyl alcohol has been widely shown to be an effective paint stripper. It is considered safe by the FDA, and several studies have proved that no significant adverse health or environmental effects result.